In this video, we're going to discuss the concept of structures. Okay, so consider a street address that is composed of a house number, a street name, a city, a state, and a zip code. You can think of them as 5 separate variables, but when you actually think of them, you usually think of them as a single unit called an address. C++ provides a structured data type for grouping separate variables called fields or attributes or members into a single unit. This is a structure and is defined with the word struct. Given the above problem, we define a structure to represent the address in C++ like struct, street address, and then we put brackets, and we give it each field would have its own declaration within the struct. Int house name, string street name, string city, and so on. Notice they all have semicolons, and the structure itself must have a semicolon at the end, which I don't show here. So here's just a little breakdown of how it gets laid out in memory. Well, here's the type the struct is defining. Each variable or instance of this type has these members, and this is one of the rare cases where a semicolon follows a closing squiggly bracket. And a variable street address would look like this, with each field having its own space. So, to declare a variable of type street address, we use street address where it's just like a type. This will create an instance of street address. The item within a struct are called members or fields and are accessed with the dot operator. So to print out the street name, we'd say cout insert address dot street name, and to assign a member, we'd say address dot city equals Palatine. Anywhere a simple variable is used, you can also use a field of the correct type as well. So here's another example. We've got a structure of type point, and it has 2 fields, an X and a Y. We can say point pt to declare a new one. pt.x equals 5, pt.y equals 5. Int new x equals pt.x plus 15. Int new y equals pt.y plus new x. We use it within the structure. So, when you assign one structure value to another, all members are assigned. All members are assigned simultaneously. For example, if we declare a structure value street address destination, then the assignment destination equals White House is equivalent to destination.house number equals whitehouse.number, destination.street name equals whitehouse.street name, and so forth. However, you cannot compare 2 structures for equality. That is, if destination double equals White House, that's an error. You need to compare each member separately. So you'd have to say if destination house number equals whitehouse.house number, and so forth. Structures can be function arguments and return values. You simply specify the structure type as the parameter value or return type as you would with any other type. For example, the following function has a parameter variable of type street address. Now, we haven't really talked that much about functions yet, but here we're going to pass in a street address, and then we can use it in here just like we normally would. And it can return a structure just as well, and here it will return a random street number. We can also have nested structures. A structure can have a structure as a member. So, for example, if we have a street address structure, we can use it in a person structure. So person, we have the name, and then we have street address for his work address. And you access the nested member in its entirety like this. Person is named Theodore. Theodore at work address equals White House. And you can also access the individual fields. Theodore.work address, .street name, and so forth. You can go as many levels as you want. And you can duplicate it. So for example, we have 2 different types of address. So that's the basics. We're going to just come over here and define a quick structure just to demonstrate how to do it. And we will say, you don't do it inside the main. We'll say struct. Let's do the address structure. Address. And then we'll define this. Put a semicolon here to make sure it'll compile. And then we'll add our field, string last name, string, that doesn't belong in an address, string address 1, string address 2, string city, string state, int zip, and so forth. So now we have created a new type. So when we want to use it, we just declare a variable of that type. And then we just use it as we normally would expect to. Can't spell. And so forth. And then we could output the address. If we run it, we get exactly what we think. So that, in a nutshell, gives us the basics of structures, which we will use in combination with other things later.